Hi everyone, Mr. Fitri here again, bringing you our second unit. This unit is going to focus in on rocks and minerals. Alright, now if this were a normal situation and we could be in the lab at school, I would show you samples of each. However, I've tried to include pictures of the rocks and the minerals. And if you're really intrigued, when we get back to school, I would be happy to show you the samples we have in the lab. That way you could look at them, touch them, examine them, and perhaps learn a little bit more than a slideshow can provide. So, let's get started. First of all, our objectives. First, what is a mineral? Second, how are minerals identified? How do we know which mineral is which? How do minerals form is our last objective. Per usual, we have some vocabulary. First, mineral is a naturally occurring solid. Second, an element, the most basic form of matter. You see in the bottom right the periodic table of elements. All right, I'm sure you've seen it before. I'm sure you understand what it's made up of, but we have to consider that our minerals are going to be made up of these elements. Everything from hydrogen to carbon to calcium and even gold and silver. Next, a solution is a mixture in which one substance is dissolved in another. This means that one substance is broken down into another. My best example I can provide is if you buy, let's say, coffee. Excuse me. You buy a coffee and you add sugar to it. All right? Now, the sugar is a solid. Right? It comes in those little grains of sugar. If you put the sugar in the coffee, those grains of sugar are going to break down. They're going to dissolve in the coffee and become one. So that's the best example of a solution I can provide for you, given the situation. Next, organic from living matter. Remember, anything that is living is organic. Okay? And we have to recognize that anything that was once living is still organic. So, a tree is organic. A dead tree is organic. If you take that tree and you take the wood from it and you make a table, a wooden table, it is still organic because it is from living matter. The opposite here, inorganic, not from living matter. Okay? So anything that was never alive is inorganic. And you'll see today that all of our minerals are inorganic. However, when we get to rocks next class, you'll learn that they can be both inorganic and organic. All right? Big distinction there. So first of all, what is a mineral? Let's see. First of all, minerals must have all 5 of these qualities. They must have all 5. Number 1, they must be naturally occurring. Okay? So they must be formed by natural processes. Okay? The earth is going to create them, not humans. They must be solid. they must have a crystal structure. This means that particles of a mineral line up in a pattern that repeats over and over and over again. Now, this repeating pattern forms a solid called a crystal. All right? And our minerals are going to have a crystal structure. 4, like I was saying a moment ago, our minerals form by inorganic processes. All right? Every mineral must be able to form from materials that were not part of living things. And 5, they must have a definite chemical composition. All right? This means that a mineral always contains certain elements in definite proportions. So if we talk about quartz, it's always going to have the same chemical composition. If it is different, it is not quartz. All right? We're going to see that in a moment. Now, something to think about, all right? First, almost all minerals are compounds. What does this mean? Well, a compound is when you have 2 or more elements that are combined so that the elements no longer have distinct properties. So let's look at an example here. We've got quartz. Okay? Quartz has a chemical composition, like I just mentioned, of SiO2. Okay? 1 part silicon, 2 parts oxygen. Now, when silicon and oxygen combine to form quartz, they are no longer silicon and oxygen. They are now quartz. And like I mentioned just a moment ago, quartz will always have this chemical composition, SiO2. Nothing different. If it's SiO or SiO3, whatever it may be, I'm not sure, it is not quartz. Same here with calcite. Calcite is a compound of calcium, carbon, and oxygen. All right, CaCO3. Again, it is neither calcium, it is neither carbon, it is neither oxygen. Combining them makes calcite. And again, it will always have a definite chemical composition. Now, there are some elements that occur in nature in pure form, and they are not compounds. So elements like copper, silver, and gold are minerals, okay? But they are not compounds. They are both minerals and elements. So almost all pure solid elements are metals. Okay, just something to keep in mind. So again, what is a mineral? It has to have those 5 qualities, and it is more than likely a compound, though there are some that form naturally that are not compounds. Okay? Our second objective, how do we identify minerals? Let's see. So first of all, you may think to yourself, well, it can't be that hard to identify some minerals. How many can there be? Well, geologists have identified more than 4,000 minerals. So with that many minerals, it can be hard to tell them apart. All right? The examples I have on the screen there, they're different colors, They have different patterns. But, these are very distinct, unique minerals. However, some are very, very similar. So we'll see that here as we go forward. First of all, we begin our mineral identification by looking at the color. Now, the important thing is that the color of a mineral may vary. It may be different. Okay? An example, quartz. All right, what we just talked about. Quartz may have a definite chemical composition, but it can form in a multitude of different colors. It can be purple, it can be white, it can be pink, it can be orange, it can be green, it can be pretty much any color you imagine. So, this is great, okay? Let's look at the color. However, some minerals have the same color or very similar. If you look to the right, we've got 4 different minerals there, and they all look blackish gray, right? Pretty hard to tell them apart. So we look at test 2. Test 2 is streak. The streak of a mineral is the color of its powder. So you see the powder on that white square in the center. That's the powder of each of those minerals. Now, why do we look at this? Because the color of a mineral may vary. It may be different, but the streak does not. The streak will always be the same. So again, going back to quartz. Quartz may be purple or green or orange, but the streak is always going to be a clear white color. All right? So those are our first 2 tests. Third, luster. Luster is how light reflects off a mineral's surface. So you see here, we've got 4 different minerals. They all look a little different, don't they? So we describe this luster as metallic, silky, waxy, greasy, pearly. All right, just how that light reflects off the surface. Number 4, hardness. Okay, so we have to use what's called the Mohs hardness scale, and it's used to rank the hardness of a mineral from 1 to 10. All right, and to determine where a mineral falls, we use a scratch test. A scratch test tells us that a mineral can only scratch minerals softer than itself. It cannot scratch minerals that are harder. So if we look to our scale here, we've got number 1, talc. That is a very soft mineral. Number 2, gypsum. Again, very soft. Number 1 and number 2 are so soft that you can scratch them with your fingernail. As we move beyond that, they get a little harder. We've got calcite, and fluorite, and apatite, okay? Here we're going to have to use maybe some metal, or a knife, or glass to scratch them. Then we get to feldspar, and then when we cross this threshold, we get to quartz and topaz and corundum, where we have to use a steel tool, a hard metal tool to scratch them. They're very hard. The hardest mineral is a diamond. That is ranked number 10. So if we look at 2 examples, what I've been talking about, calcite and quartz. Okay? Our scratch test tells us that quartz can scratch calcite because it's softer, but calcite cannot scratch quartz because it is harder. Okay? Now, a little did you know. Apatite is a mineral on the Mohs hardness scale with a hardness of 5. Do you see it? Yeah, there it is. Okay. Now, why do I pull out apatite? It's because enamel on teeth consists mainly of apatite crystals. So your teeth have minerals within the enamel. So your teeth are pretty strong, all right? They're on the Mohs hardness scale. Interesting. I think so. All right, back to some serious stuff again. Number 5, for our identification, we look at the density. Each mineral has a characteristic density. Now, it doesn't matter how big or small the mineral is, or how big the sample is, the density of the mineral will always remain the same. Okay? We have to look at the crystal structure. All right, geologists classify crystals by the number of faces or sides on the crystal and the angles at which the faces meet. So you see a bunch of different crystal structures in that chart there. You also see different sides, different angles, different shapes. Number 7, we look at the cleavage and fracture. This may be a little difficult to understand because we can't look at examples, but try our best here. Cleavage is when a mineral breaks easily along flat surfaces. Okay? So if a mineral breaks and has a flat surface, it's going to exhibit cleavage. On the other hand, fracture describes how a mineral looks when it breaks apart in an irregular way. Okay, so it's not going to be flat. It's going to be bumpy or rough or something like that. When a mineral breaks like that, it exhibits fracture. Number 8, last one here, special properties. So some minerals, not all, just some, can bend light, some can conduct electricity, and some glow under certain lights. Some are also magnetic. So, how are minerals identified? Well, we've got a bunch of tests we have to conduct on them to determine which are which. All right? And I hope I've outlined those tests adequately. Okay. Now, how do minerals form? Easy peasy. So, first of all, minerals from solutions. So, when elements and compounds are dissolved in water, leave a solution, crystallization occurs. All right? Again, dissolve. This is to make a solution by mixing with a liquid. So something broke down in a liquid and has slowly crystallized over time, formed minerals. The other is minerals from magma and lava. All right? This is when minerals form as hot magma cools inside the crust or as lava hardens on the surface. Okay? When they cool to a solid state, they form crystals. Now, just a last piece here, mineral formation. Now, Earth's crust is made up of common rock-forming minerals, which combine to make rocks. And these are going to be pretty much found everywhere. North America, Australia, everywhere. However, there are less common minerals, and they're not found evenly in the crust. They tend to be found in specific locations. So if we see here, we've got some specific minerals. All right, things like bauxite or diamonds or silver, manganese, lead. You can see they're not found everywhere. They're found in very specific locations around the world. So let's zoom in here a little bit. So here we've got Asia. This is the best I could do without messing up the quality of the picture. So we've got Asia and Africa and Europe and Australia. But let's look specifically here a little bit at Asia. All right, you see where Thailand is. You've got tin being found, maybe some copper in northern Thailand, some zinc in Myanmar. If you go down into Malaysia, towards Singapore, you've got chromium and bauxite. If you look north into China, you've got a multitude of things like lead, manganese, copper, bauxite. If you look west into India, you've got a bunch of different minerals being found there. Again, here's a little different take on it, adding a few more things, okay? Again, if we look at Thailand, you see again, we're finding other minerals, okay? Along with, just in the middle of Thailand there, you see a little oil rig, so oil is found. If you look in the Gulf of Thailand, you see some natural gas being found. And in the very north of Thailand, towards Myanmar and Laos, you've got forest products. Okay, maybe some special wood products. Okay. So this finishes off our minerals lesson. So please review these. I really wish we could be in the classroom to examine these samples we have. It makes class a lot more fun and interesting if you get to touch and feel and examine under a microscope, or I'm sorry, under a magnifying glass, these samples. But that is the situation, is it not? Anyway, please let me know if you have any questions. I hope you have a great day. Talk to you next time.